Bob Alsop with ShopSabre CNC. Around here they call me RouterBob. I've got a video today I think you're really going to like. We're featuring the ShopSabre 23 machine, which happens to be one of our smaller machines. But I've got a really neat project to make, and the whole process is called VCarve Inlay, and I think you're really going to be amazed at it. Now, let's look at this machine before we get started. The ShopSabre 23 is actually a fairly small format machine, but it's built like our big industrial machines. Now, let's take a look at the frame itself. The basic frame is a one-piece all-welded frame of structural steel. We have gantry supports, and then we also have a gantry that's tubular steel. Tubular steel just gives you better cuts and a better finish and allows us to cut much faster. Now, let's look at what actually makes the machine move around. Okay, motion control on the machine is actually controlled by several different components. For one thing, in X, Y, and Z, you have precision contour guide rails. That's actually what the machine travels on, and those have preloaded bearings, so there's no play at all on it. Now, what actually pushes it are ball screws. These are precision ball screws in X, Y, and Z axis. So that makes a really high quality machine. That's why we get such great cuts. It's because we use a ball screw system, the frame's heavy, and we got great guide rails. Now let's look at the other part of motion control, and that's the machine control itself. The ShopSabre 23 has our exclusive ShopSabre CNC controller. Now let me tell you a little bit about that controller. We started out with a real robust control technology, and then we built everything on top of that. That's actually what connects to the other components on the machine, in the motion system. Then one of our goals was to create a user experience that made it very simple to run the machine, didn't take a lot of training, and that you could realistically have a typical employee learn how to run the machine in a very short period of time. One of the other things that we wanted to do was to be able to integrate that whole machine system into our company network. Now, the reason why we wanted to do that is so that we could actually send files to the machine control from the front office if we wanted to by network. We also wanted to be able to run software at the machine control, so instead of having to go back to the front office to get a program done, we could do it here. Well, the way we accomplished that was we used a PC on the front end, and we actually display the machine control on that screen. So the machine operator interacts with the machine there. That opens up the network capability of the system, and it also allows me to run software on the machine control. That's worked out really well. Now, let's take a look at the router spindle on this machine. The ShopSabre 23s come with a variety of spindles. Now, this was not actually a spindle, this is a Porter cable router motor. And you might say, well, why would you do that? Well, number one, they're very inexpensive, so it's very economical to use those. Replacements aren't that expensive. But the real benefit is, if you use that system, you can run a machine on 110 volt power. So if you have electrical limitations in your shop, this might be a solution. And what's amazing about it is because you mount this on a robust frame, you'd be very surprised how well this machine cuts. Now, let's talk to the table about the table, and let me explain this fixture I have on the tabletop. These machines are available in a number of different table material options as well as table design options. This is actually an MDF version that's a T-slot table. We can also supply the same design with phenolic if you prefer that. All of the tables with T-slots features actually have steel plates underneath that those are bolted down to. So it's a really rugged clamping system, so you can put a lot of pressure on stuff to hold it down. Now, this is a good example of why you'd use a T-slot table. This particular setup is we're going to make a VCarve Inlay, and so we need a way to fixture it. So we basically put a piece of 3/4 inch white melamine, we've clamped it down, and then we're actually going to tape our boards on here and do the machining. Now, let's go into the office, let's look at the software, and then I'll show you how we toolpath it, then we'll come out here and actually make that sign. Okay, now let me explain to you what we're going to do in here and what we're going to do on the machine. You saw the setup on the table. What we're going to do is a process called VCarve Inlay, okay? Now, typically in inlay, you're basically cutting a pocket out in the substrate material, and then you're putting something inside the inlay. But you know, traditionally your problem with that is you always are locked into the tool radius. So I can't do a sharp inside corner, I'm stuck into whatever size tool. Well, there's another process, and we're going to be using VCarve Pro to do it, that's called VCarve Inlay. What happens is you basically cut the VCarve pocket out with the typical VCarve process, then you take the same graphic, you mirror it, and you cut an opposite of that, and what that creates is a plug. And then you take the original, you take the plug, you glue it in there, put it back on the machine and machine it all off, and you end up with an inlay, and it has really sharp corners. Let's look at that a little more closely now. Okay, it starts out like any other VCarve project. You have to have some kind of graphic. You know, sometimes you have lines that you're going to use. What I wanted to show you is this step is how you take like a really nice graphic and first off start with the vectors that you can machine. So this is a ShopSabre banner. The part I really want to use is this section right in here. So the first thing I have to do is turn that into some kind of lines, and there's a process in VCarve Pro. It's a little sign here. It looks like a bird or a button. It says Trace Bitmap. So I'll click that, and I've got this slider here. And the slider comes along here. What I'm looking for is just contrast. Okay, that actually looks pretty good. Let's hit preview and see what it looks like. Okay, the lines look pretty good. That's probably good enough. Okay, I'm going to slide down here. And oh, by the way, you can play with a lot of these different settings. This is a really good graphic. Sometimes you're not that fortunate. I'll hit apply. Now, what that did was that created the lines. All right, well, how do we separate them? Well, if I go to layers, I'm going to turn off the bitmap layer. That's where the graphic is, and those are the lines that are left. And you know, I'll give them a good inspection. Now, that looks really good. I'm real pleased with that. I think first I'll get rid of the ones I don't need. So let's just select these out. Whoops, okay, that's grouped together, so ungroup it. Okay, let's select these out. Delete those. Delete those. And delete those. There's one right there. I don't know what that was. But you see, I can basically take vectors off all that and just get rid of the ones I don't need. So this is a process that I use to create the actual graphics that we're going to machine. But I wanted to show you how you take a graphic image and do it, because you don't always have the luxury of having vector artwork. Okay, that looks pretty good there. Everything looks good, and once again, this is a really good graphic. Now, if I want to resize it, all I do is select it. I come over here to this icon and type in what size you want. In my case, I think I wanted it 15 inches. Now that's sized to the correct size. So that's the first step, and that is, start with the graphic that you want to use. All right, now let's go further, and I'll show you how I actually use those graphics to create the toolpaths. Okay, now let's look at the screen here. If you remember, before we came in here, we looked at that fixture setup that's on the machine table. Now, let me show you what some of that is. You notice that there was a piece of 3/4 inch white melamine board. It was about 24 by 24. That's what this boundary represents, to give you an idea. Okay, then this area right in here, this is the blank. And our original blank is large enough so we have a boundary around our actual logo. And if you notice, I put the origin is in the center. And that's how and I located that on the machine that way, and that's how you figure out where this locates on the machine. Okay, so that's what we did first. And the first thing I actually did before I did anything else is I went out, and sometimes people say, well, how in the world do you know where to put things on the machine? Well, I do a thing I call setup. So the first thing I did, we'll just look at simulation, you can see this. So the first thing I did was cut a toolpath around there. So I basically took a 1/4 inch router bit, went around the outside of that line, and cut it about 30 thousandths deep. Now I have a boundary on there, and I know where to put the board on. We're going to actually hold these parts down with double stick tape. And once again, it's because we're prototyping. We're not making a big production run of this. So double stick tape holds the stock on there. And of course, it sticks very well to white melamine board. So then I cut a shallow groove around there so I know where to locate the board. Once again, that's how you get things to line up. A couple other things I did. I also went in and cut a smaller one, because we have, in this process, there's actually 2 pieces of wood that we're cutting, and one's smaller than the other. And then there's another thing that you may not have thought about doing this, but if you notice, I machined some holes here. And they're basically 3/4 in diameter, and they're 1/4 inch deep. And when you use double stick tape, sometimes you have a problem of prying the part off the table, especially if the tape really sticks well. So what I do is I machine 4 pockets into that melamine board so that when I'm getting ready to take the part off, I can slip a tool underneath there and pry it up. So that works out pretty good. So our first thing is to actually then do our machining on the melamine so we know what the setup is. And those are just setup tool paths. Now let's look at the graphic end of this. Okay, now let's talk a little bit about some issues you might have when you actually use double stick tape. In our case, we purchased some S2S material that was already plain, and it wasn't that smooth, and it was a little hard to tape down. So what we ended up doing is we double stick taped it down, and then we took a fly cutter and we actually faced it. And so the fly cutter, we actually used an 1.5 inch cutter, and we went across there back and forth. We took about 30 thousandths off, and that gave us a perfect flat plane. You may need to do that, or maybe you don't need to. It depends on how your material's prepared, but I want to tell you that might be a step that you want to do. Okay, now let's look at the actual machining. Okay, here's where we positioned our graphic, and it's centered on our material blank. All right, now it's just a typical VCarve operation. So you open this up, and we selected a tool. We're actually going to go to a certain depth. We're telling we want a flat depth of 0.1. We're using a 90-degree V-bit, and it's just simply a VCarve operation. So when you do that, you get 2 tool paths. You get that one, and you get this one. The first one that you get is basically the pocket. Now let's look at that simulation. You can see what happens. So here's simulation. So the first thing that we want to do is we want to take this pocket. Okay, so what this is actually a flat area that's going to be cut out with an 1/8 inch tool. That's what that is. And when you simulate it, this is what it looks like. Okay, then we change tools. Everything stays the same. We change tools, and then we run this program. And this program is a V-bit. So now we use the 90-degree V-bit, and that's what it looks like. Now that's no different than actually doing a VCarve sign. There's no difference at all. So that's the first phase of this process. Now the second phase is to make what we call the plug, and we'll talk about that in just a second. Okay, now what makes this a VCarve inlay is the other piece that we make, and it's basically a plug that's the opposite of what we machined. So let's take a look at that. So let's turn this layer off, and let's look at plug. And you see now, first off, it had to be a mirror image. So what I did is I took that same graphic and just mirrored it, because it has to be a mirror image, because we're actually going to fit it in there. Right now, I added another piece of geometry, and that's this one, because we have to create a boundary. Right? Once again, it's a typical VCarve setup. When you're using a separate tool, you get 2 tool paths. We're using the same tools. Here's what's going to happen. Let's look at the simulation. Okay, so the first thing that's going to happen is the 1/8 inch bit's going to be used to cut that out. Now let's put some color in here. You can see it. So basically, the piece that we're actually using here is smaller. It's not as large as the overall blank. I just needed to make the piece small enough where it would actually, it was big enough for the plug, and that worked out fine. And then once that's done, then you put a V-bit in there, and that runs, and that creates a plug. And then that plug then is actually glued into the VCarve piece, the first part we made. And then you let the glue dry. Okay, then our final operation is we reintroduce that back onto the machine, and we just keep machining it down until what we have left is just the plug. Now, probably a good way to show that would be this. This is probably more likely. Let's simulate that one and that one. So what happens is once you've machined that off, basically what you have is this. And where you see blue here, this is actually that contrasting color of the wood that you made the plug out of. So it's an unbelievable effect. So now we've got all our tool paths together. We already know how to do the setup. We've already got the fixture set up on the machine. So now let's go out there and let's go through this process, and let's see what our sign looks like when we get done. All right, now we're back out here in the shop. Let me bring you up to speed on the setup. Of course, we looked at this earlier. Now we've double stick taped this part down. This is going to be that first cut that we did on the software. I want to make sure everything lines up well, so we're actually going to put an 1.5 inch straight bit, and we're going to cut back and forth, and that's really going to face that. That's going to give us a really, really flat surface, and then that's going to make everything else line up after that. All right, let's get the machine cranked up, and let's make this part. Oh, by the way, one other thing. These machines come with dust collector shrouds. I'm going to leave it off for these operations so that you can actually see the cutting action. I think you'll understand a lot more if we do that. Let's get started. Okay, our first operation came out really good. This is really no different than making a VCarve sign. Now, let's take this board off, we'll put another piece off, and we'll cut the part that actually becomes the plug that really makes this a VCarve inlay. All right, this came out really good. This was the piece that's the plug. This was the original VCarve. Now what happens is this is an exact opposite of that. So it gets lined up here and it should drop right in if I get it aligned correctly. Somewhere, there it is. All right, that gets glued in. And then once the glue dries, then we'll come back over and we'll machine that off. If everything works right, our 3D engrave is going to be filled with walnut. And you should be able to see these square corners coming out. So let's go glue these together and then we'll come back over here and do the final cuts. Okay, now we've got our assembly back here on the table. We're attached with double stick tape. Now what we're going to do is just gradually machine this walnut piece off, and when we're finished, we'll face this entire bottom surface here, and that should leave walnut down in the V-carve grooves. Let's see how that comes out. Oh, this came out great. This is perfectly level on here. Let's take a look at that now. Oh, that's beautiful. You can see how basically the 3D engraved part was filled with walnuts, what it looks like. And the beauty of doing a VCarve inlay is these corners are square. On a normal inlay, you're stuck with the tool radius. So isn't that beautiful? You know, I think what I'll do is put a little bit of oil on there to bring that color out a little bit. Boy, that's nice. Okay, we just finished putting the oil on there, and boy, did that come out good. The oil really brings out the contrast. You can see the nice walnut, how dark it is, and you can see how pretty this birch is. It really is a great effect. You know, I hope you enjoyed this video. I wanted to accomplish two things. One was I wanted to show the ShopSabre 23 machine, and I wanted to show you how to make something that maybe you hadn't thought of before. If you have any questions, you can contact us at www.shopsabre.com. Thank you for watching.